Hello everyone, I'm KHAOULA Tarik, a PhD student at Ibn Zohar University, Faculty of Science, Agadir. My presentation is about an application of the analytic hierarchy process for influential nodes classification. The plan of my presentation as following. We start with introduction, then AHP methodology, next empirical study, and the last conclusion. So in the field of network science, and especially in complex network, each node has a particular role. Therefore, some nodes they may affect the structure and the function of the network to a greater extent than others. So the identification of these influential nodes is essential in many fields such as network attacks, information dissemination, and epidemic spreading. Various measures called centrality measures are proposed to identify these nodes, but each measure has its limitation. For example, degree centrality, although its simplicity and low time complexity, the entire system structure is ignored. For between centrality and closeness centrality, they consider the whole network, but these two centralities are not as impactful in large-scale networks. AHP methodology or analytic hierarchy process is a multi-criteria hierarchical analysis. It's invented by the mathematician and professor of Wharton School of Business, Thomas Sati. It allows comparison and choice between preset options and based on the comparison of pairs of options and criteria. It's developed to optimize the allocation of resources when there are several criteria to consider. Four fundamental principles of this method are hierarchical structure, extraction of priorities, logical consistency, and semi-quantitative method. The proposed method is composed of the following steps. Step 1 is modeling decision problem as a hierarchy. Step 2, computing a matrix of decision criteria, which means the importance of each criterion is determined to another according to the Sati scale. Step 3, computing a matrix to compare different solutions for each decision criterion. Step 4, computing a matrix of solution. Step 5, ranking the solutions. The proposed methodology is AHP combined with the best well-known centralities, which means we let this centrality meters as multi-attribute for analytic hierarchy process. So we start with modeling the problem as a hierarchy. We calculate different centrality measures. We let centrality measures be the multi-attributes in analytic hierarchy process. We calculate the weights to each attribute. We calculate the matrix of nodes comparison for each centrality measures. We calculate the matrix of solution scores, and then we calculate the global score of each node. And the last, we can classify influential nodes according to their global score. So, in light of what has been proposed, basic model is given to show how analytic hierarchy process acts in this part. So, this model is basic, is composed of 11 nodes and 16 edges. In analytic hierarchy process, a problem is structured as a hierarchy. A diagram is created according to the objective of the study in the top level and the criteria and sub-criteria in the lower level and alternatives or solution in the bottom level. So the objective of our study is the classification of influential nodes. Criteria are the three well-known centrality measures: degree, betweenness, and closeness centrality. Alternatives are nodes from A to K. In the hierarchical analysis process, the importance of criterion I compared to criterion G is determined. Of course, we use SASI scale for determine the importance. The value is assigned to the position IG, and automatically the inverse of the assigned number is associated with the position GI. For example, comparing closeness centrality with the degree centrality, we assign the value 4 in the position 3, 1, and in the position 1, 3, we assign the inverse 1 of 4. The following step is to construct for each centrality meter a matrix that compares each node to the others depending on each criterion. So we start with the first criterion is degree centrality. We rate each node according to others, of course considering the different values calculated already by using R software. The same thing with the second criterion between centrality. We rate each node according to the values calculated by R software, and we rate using SASI scale. And the same thing with the third criterion, closeness centrality. So from these matrices cited above, we can extract the matrix of solution. This is the matrix of solution, and by multiplying this matrix with the weight of each criterion, this is the weight for degree centrality, the weight for betweenness centrality, and degree for the closeness centrality. By multiplying these weights with matrix of solution, we can have the global score of each node. And of course, if you passed off this score, we can rank these nodes. So this schema demonstrates the rank of the score of each node. So G is the most influential one, and K is the low influential. Also, from the table, we have the rank of this node using the three centralities and our method AHP. So G and C is the two important node using all these methods, and K is the last one in all these methods. Also, from our method, we can know that if we analyze this rank, we can know that G is classified as the most influential node in the network. It has an important role to connect the two parts. If we see the network, we can go back to the network. So our basic network, this is G. So it's crossing important node, and it's close to all other nodes, and it has a lot of direct contacts. So it's too adequate to be positioned first. Nodes C, D, and G are the following. Effectively, they are more important due to their closeness to the most central node G. Node B, F, A, E, I, H, and K are classified in the back of the network on account of their position at the periphery of the network. For sensitivity analysis, we use the software Expert Choice 11 to test the variation of the weights. Performance sensitivity analysis of nodes has been analyzed when degree centrality between and closeness centrality is increased by 15% from its current level respectively. In order to show the stability of the classification of nodes. So this is the original, this is the performance sensitivity of nodes given by expert choice for the H per rank. When we increase the degree centrality by 15% at the current level, so the rank is the same. This is nodes. The same thing when we increase between centrality by 15%. We have the same rank. Also, for closeness centrality, the same thing, which means we have rank stable, which means we don't have to review yet the weights of centrality. To conclude, the identification of influential nodes in a complex network is an important research topic. Many methods are proposed. In this communication, we have shown how the original analytic hierarchy process behaves to identify influential nodes in a given network. We consider different centrality methods as the multi-attribute of a complex network in this application. And the empirical study demonstrates that the original AHP gives good results in terms of influential nodes identification. There are some references used in this work, and thanks for your attention.